Yeah, and thank you everyone for attending. Today's topic is going to be plotting with delta RMCs. And so we're going to go ahead and do a kind of an overview of just the plotting application in general and what we can do with it, some strengths that are there, and then we're going to dive into a little bit more of the details if you're already familiar with it. So one thing to note before we get started here, um, if you are unfamiliar with RMC tools, with the RMC product family in general, we've got a lot of great Delta videos that will basically take you step by step through a nice introduction to the RMC. So I'm going to be covering things kind of quickly here, but if you feel that, for instance, you would like some more information on just basic motion control, this video sequence is a great place to start. We also have a library and schedule of webinars. There's many past webinars that we've done, so if you enjoyed this or if you'd like to go and see what we already have available, we also have a library on our website of all of our past webinars. Okay, so a brief plot overview. The idea behind a plot is fairly simple. We're going to be viewing real-time data, and we're able to plot any register in the RMC. So for instance, with this plot, we've got our target position. It's difficult to see on this plot because it's tracking very well. We have actual position, which is right on top of our target. Um, we've got a target velocity, an actual velocity, and a control output. And so these are just some basic items that are on most every plot. Let me jump to RMCTools. I've got a project set up here. Right now, we're set up in simulate mode with our axes, so we're able to move just as if it was a real physical system. So what I'm going to do is go to plots. I'm going to open this up here. I've got a few plots that are already configured. We'll talk about setting these up in just a minute. But what I'm going to do is go ahead and trend a plot for axis 0. Now you can see that I've got the same data items here in my plot details window that I did in that slide earlier. So if I, for instance, send a move to 15, right? We can see in real time what's going on with this system. I'm going to send another move. I'm going to move it back to 10. And you can see that we're moving back and forth. You can see that I can scroll around here. There's a lot of things we can do with these plots. If you look at my cursor, you can see that as I move this cursor here, all the items, all the quantities in my plot details window, they're being updated as well. So by moving this cursor around, I'm able to see exactly where everything is. Again, this is a basic plot setup. So I've got target and actual position, target and actual velocity, and my control output here. But this is the basic idea behind plots. We want to be able to see this data in real time. Again, just a quick note, as AJ mentioned in the beginning, if anyone has questions, feel free to jump in. AJ will be monitoring those and he can jump in with your questions and we'll try to answer them as we go. Okay, so what applications do we have for plots? Well, of course, startup is a wonderful place where you're going to be wanting to use plots. You're able to see how things are tracking. We're able to see if you're actually able to get movement or not. Sometimes it's difficult if the physical system is hidden, but with the plots, you're really able to see, exactly how much movement you're getting right from the startup. Tuning is another area where plots are basically a necessity. Very difficult to do tuning without the plots, and we'll go into that a little bit here a bit later. Data acquisition. Some of you may have seen a previous webinar where we talked a little bit more about this. I'll talk a bit about this here as well, but data acquisition is another big use of plots here. In this example, I've got a LabVIEW driver that we have set up, and it's actually capturing these plots in real time. troubleshooting. I'm going to talk a little bit about some of the tools that we have that we can use with plots, ways that we can capture these plots, and just different things that we can do if you have a tricky problem that you're trying to trace down and it's difficult to get to the root of it. And there's many more applications as well. Okay, so using plots, the first thing that we're going to be doing is creating a new plot template. So we would jump into RMCTools, jump into our plot template editor, and you can see that we've got a few just default items that are already set up here. If that's all you need, that's totally fine. For a lot of instances, really the default items are all you need. But if you would like to add something more, say multiple axes to a plot, we can do that as well. You're able to, instead of going to a default, you go to a custom plot, and then from there, we're able to select any data item that you'd like to add to your plot. So let me jump back to RMCTools and we'll set up a plot. Okay, so I'm still in my plot templates. I clicked Edit Plot Template, and now I can see this list of all my plots that I have set up here. And I've got a few that have already been set up for this presentation, but let's go ahead. We'll add a new plot. So you can see as soon as I click this Add Plot Template button, a new default plot template opens up. I can change this to any of the axes that I have configured on my RMC. Right now I'm using an RMC 200, and you can see I have it set up for 21 axes here. So I'm going to say for this plot, I would like to see both the target and actual position for two axes, maybe axis 1 and axis 0. Perhaps you have a problem or an application where you're synchronizing two axes together and you want to see them both in real time. So what I would do is click Custom Plots. I've got some information that, while useful, maybe I don't want in this specific plot, so I'm going to get rid of my target velocity. I'm just going to click this Delete button, actual velocity, control output, status bits, and my position mean squared error. I'm going to click New Quantity. Now there's a few ways that I can do this. First way, I can browse axis 1, status, feedback, actual position, right? Because I wanted actual position and I wanted target. Then I can go to target, actual position, or target position rather. I could click OK here. Now I've got two more items. But there's a neat feature that was added just recently. This is especially helpful when you have lots of axes that you're trying to plot at once. But I can click New Quantity. I can click my Duplicate for Axes button. And I can choose either from items that I've added in recently or items that are already inside my plot here. I'm going to say that I'd like to duplicate target position and actual position. Then I have to select which axes I want to duplicate these items for. I'm going to say axis 1, click OK. It'll add these two items into my quantities. Click OK, and you're able to add it that way as well. Okay. I'm going to go ahead and change the pen color on these, make it something that's a little bit easier to see. All right, and now I have my custom plot here. So I'll go ahead and trend this custom plot. If I move to 15, we can see that move on axis 0. Let's go ahead and move to 15 with axis 1 as well. So with this plot, now I'm able to see both of my axes move at the same time. Okay, so we selected our data items to plot. A few other things that we can do with these plots, zooming and panning. We're able to zoom around on these plots. We can zoom deep in and see individual points in the plot. We have a second cursor that we can use to trim a plot. We can also use it to measure the time between two points. So in this case, we'd be measuring the time here between 2 points. And we can correlate the plots with our event logs. So we're actually able to look at the plot. We see a real-time register there, and then we're able to look at our event log as well. If you're not familiar with the event log basically it tells it all in its name, right? It's a log of every single event that's happened since the RMC has started up. So we're able to see the commands that have been issued from this log. Let me show you what that looks like. Okay, so here's RMCTools, right? Maybe I want to really zoom in on a certain point here. Well, I've got a few options. I can hold down Control and use my mouse wheel. That's what I'm doing right here. I can also press my zoom button here, but you can see as I start to zoom in further and further, I start to see individual points. Each of these points for this plot are taken at 1 millisecond at my sample interval. So I can see that the distance between these 2 points, I'm going to show my second cursor, and I can see now that I have a second cursor, I have a time difference item here. I can see that the difference between those 2 points is 1 millisecond. That second cursor is very nice for quite a few things. So perhaps I want to see what the time difference is between when one axis rose to 15 and the other rose to 15. Well, I can see here my time difference is roughly 7 seconds. Now, one other thing I want to show you, so if I look at my main cursor, I can see that when this command was issued, my absolute time was 1 day, 21 hours, 59 minutes, 12 seconds, and 448 milliseconds. If I go to my event log's just very last item in your project tree, I can see exactly when that command was issued, right? So the command that I'm looking for is this one here, and you can see that it correlates, the time right here correlates right to the plot. So you're able to take your plot and take your event log, and you're able to correlate them together. This becomes very, very helpful when you've got some tricky logic problem. Say you're unsure why an axis is moving, you don't think that it should be at that time. You're able to go to your event log and compare it with a plot, trace down what commands are being sent and what you're physically seeing, and it will just lead you right to what you need to do very, very quickly. It's a really nice tool to have. Okay, let's jump back to our slideshow here. Now, we can add any register in the RMC to a plot. What we saw before, we were adding some more basic registers. We were adding axis 0 and axis 1, target and actual position, but it doesn't just have to be like that. Maybe we want to add something like a variable or a calculation. If we want to do something like that, we can also change our scale. Generally, our scales are set up to just auto scale, and it does a great job most of the time. But if you say have some kind of a custom register that's going in, maybe you want to set your own scale. We can also group the items together. So say you've got a few items that are all position. Well, you can make sure that they're in the same group. And again, the RMCTools does a great job of grouping these together how they need to be. But if you have something custom, you may go inside here and make sure that everything's in the same group. We've got a few ways to add calculated quantities. One of them is just going into our plot quantity selection tool. You can click on the Advanced tab, and you can choose the type of formula that you'd like. So for instance, if say you'd like to see the rate of change of a variable, well, we can enter that in here, and we're able to see what the rate of change is for that variable, right? You know, basically the change or the velocity in an item. Maybe you have a variable that's actually a position, and you'd like to see what that rate of change is. So let me jump into RMCTools. I'll show you a application where something like this is going to be very useful. Okay, so in this application, I'm going to say that I have a specific process, And in this process, I want to make sure that my axes are always synchronized together and they're tracking within a window of each other. I want to make sure that they're tracking very well and um, that they're not going out of whack. They're not getting out of place. Well, in this case, what I'm going to do is have two curves. So I'm going to be measuring the skew between two axes. Let me show my actuator view. We're going to say this is axis 0 and axis 1 that we're going to be looking at the skew between. So I can see right now they're both lined up. I want to make sure that they stay lined up, that they don't skew too far from one another. So I'm going to be looking at the axis 0 and axis 1. And I'm going to say, as I'm going through a motion profile, I've got a skew lower and a skew upper limit. And I want to make sure that I'm in between these limits as I'm going. So I'm going to be running this program here, this sync move command, the sync program, and it's just continuously moving axis 0 and axis 1. We do a few different moves. If you're interested in learning a little bit more about programming, I'd recommend checking out some of our other webinars, looking at some of the other videos that Delta has to offer as well, or just go ahead, let us know. We'd be happy to talk to you a little bit more. I'm not going to go really in depth into how this program is set up here, but what this is doing is just going through a process. We're moving to different positions and we're changing our speeds with axis 1 and axis 0. Okay. So I'm going to run this program here. And what this program here does, I start my synchronization task, and I'm also, again, I'm using an expression here. I'm doing a calculation, and I'm going to be looking at a plot that is going to, plot my upper bound, my lower bound, and it's going to also plot the average position so I can see what my skew is between my axes. All of these items are going to be included in the plot. So I'm going to show you what this looks like. Let's run this here. And I'm going to run this one more time for you after this stops, just so we can see how it looks. Okay, let me run this again. Be able to see it on this plot here. I'll stop this. I'll show you all the quantities that we have, kind of what we're going for, and then I'll show you how we put it into our plot. Okay, so let's first go ahead and look at our profile. This is the profile that we've generated here. You can see it looks like these axes, axis 0 and axis 1, they're a little bit off from each other. I also have axis 0 target position, and this is kind of the master target position that both should be following. So if I look at axis 1, you can see that axis 1 is tracking very well. Axis 0 has a little bit of overshoot, a little bit undershoot. It's not tracking quite so well. So if I plot these two together, you can see that there's a skew between these. I'm going to show you what the skew actually looks like. This green line here is the skew. So you can see as I get farther away, my skew will start to increase and decrease. I want to be at this line 0 right here. You can see I go negative in some spots and I go positive in others. This would tell me that I probably need some tuning on my system. But I also have my skew upper bound, this brown line here, and I have my skew lower bound as well. So I can see that I've got two bounds, upper and lower, for this whole time. I want to make sure that I'm in between these two lines at all times. The other thing that I have inside here is my skew error. So these lines will go high if I'm over my bounds, either in the negative direction or the positive direction. So I can see right here, right where I cross over my bound, well, I get a high on my skew error. And then I come back in and that skew error goes away. Same thing here, I go a little bit over on the top, I get that error. And same deal with these points here. So you can see that there's a lot going on with this plot. Again, these items are all being calculated in a user program that I have running, and I'm then using this plot quantities to plot all of these items. So let's take a look, and I'll show you what I've done here. I've put some of these variables, the skew upper bound, skew lower bound, skew error, and skew. These are all variables. If I click new quantities here, I can go to my variable table, and you can see that all of these variables, right, my skew, skew upper bound, skew lower bound, skew error, these are all items from my variable table that I've decided to plot on this plot here. Now, to have these make a little bit more sense while they're plotted, I've also included a group, a manual group. So I put each of these items on group 1 because it's difficult for RMCTools to know exactly which group of variables should be placed in. But I know that these are all going to be on group 1, so I've placed them all together. If I really wanted to see how tiny this error is or how large it is, I could place these on the same group as axis 0 and axis 1. So if I decided to put these both on group 1, click OK. I can trend this again. Let's run this program again, and you'll see how my error has shifted. So it's a little bit more difficult this way to actually view what's going on with this skew here. Get rid of this. I didn't place the target on here. You can still see, right? You can still see that there's the skew, but it's been placed on a totally different scale. You can also see that it doesn't look quite as severe as it did before, just because it's compared with the actual position there. But maybe you really want to see, exactly what the skew would look like. Well, then you would take things and you would keep them on their own scale group. So I would most likely just leave these both on auto, keep these on their own group, and then it's very easy to view something that's kind of more complicated like this. Very nice tool, and you can do it all inside the RMC. So for instance, if you want to then take all this data, send it all to an HMI so that someone can see it while you're in production, you can do just that. You can send everything from these plots. Okay. This example is a little bit more complicated. If anybody's interested in doing something like this and would like to talk a little bit more about it afterwards or in a few days, just let us know. We'd be happy to talk to you more about it. Okay. One other thing to note here, each RMC has a plot template memory usage item here, and so you can see if you have maybe you have a lot of plots with items that you want to capture, and perhaps they're very long plots, you'll see that the memory is going to start to fill up. If you're interested in optimizing that, maybe getting rid of some plots that you don't need and because you're going over usage, you can click on this template memory used here, and you'll be able to see which plots are consuming the most memory. So this is just a few screenshots from my project here. I'll show you what that looks like in RMCTools. You can see here I'm only using 0.3% of my plot memory. I click here, you can see how much memory each of these plot items are consuming, each of these plot templates rather. Okay. Some of you may already be familiar with this, or maybe you've noticed it as I was going through, but there's two ways that we can actually grab plots. There's our capture. We haven't used this one just yet, but the idea behind the capture is it's going to be triggered on a single event, right? It's generally a single event that happens. We capture some plot and we save it in the RMC's memory. So we capture for a set amount of time. We set this up from a template, and we're triggered off a certain condition. The default for these captures is that we'll be grabbing a plot whenever there's a new motion command sent. But we can change this and we can do manual captures, and there's a few reasons why that would be useful. We also have the trend button, and that's what we've been using here through the webinar. We can start and stop this from RMCTools, and this is generally going to be used for setup and diagnostics. Trend total duration is set in the plot template as well for this item. So let's go ahead and we'll look in RMCTools. I'll show you the difference here. If I look at this plot that we've been using, you can see that I've got a capture duration. Right now that's set for 1 second. And I also have a trend duration. Right now that's set up for 30 seconds. So if I start trending, I'm going to be capturing 30 seconds of data. You can see you can increase this quite a bit. Once you start to increase this more and more, we'll start to give you a warning. Plot trend may consume 2.1 gigabytes of PC memory, so we'll start to warn you. And if you go way past where you should be, past 4 gigabytes of PC memory, we'll say, that's kind of the limit. You can't go any further with your plot there. But we try to make sure that you don't run into anything where you're going to be causing issues with other applications. Okay, and same deal with the capture duration. You can see I can increase this capture duration, and you can see that as I'm adding zeros here, my plot template memory usage is increasing as well. So I add another 0, I go to 12% there. Now I'm at 119%. If I click on this little error marker here, I can see what's going on. But yeah, so it will tell us exactly where we can be. I'm going to keep this at 1 second, and I'm going to keep this at 30 for now. Okay, so we already have seen the trend. Let me show you what the capture looks like. So if I click capture here, I can see that it's grabbed my last motion command. Let's go ahead. I'm going to send another one. Let's see where we're at right now. We're at a position of 1 with axis 0. I'm going to stop my program here, and I'm going to move this to a position of 5. So I move there. I'm going to click capture now, and this will be capturing 1 second of data. All right, so I started here, 1 second, all the way at this end, I've captured, and it shows me right from when I issued this move command to the end. You can see I got to 5 here. So capture is very useful for a multitude of things. It can be really great when you're trying to troubleshoot, trying to capture an intermittent issue. You're actually able to go in, and we're actually able to set that up so that it only captures based on an error condition. And I've got an example I'll show you here as we're going through where we're doing just that. Okay, so every RMC has limits to how much storage there is, how many data items, and how many plots you can achieve for each. You can see with the 75E, generally it's used for 1 to 2 axes. Max plot templates is 8, and you can have 16 data items on each plot. We try to give enough space that you shouldn't run out of plot templates or data items. So as the controller axes increase, for instance, with the 150, now you're up to 16 plot templates, 16 data items each. And then with the our CPU 20L, we're at 48. And for the CPU 40, we're at 64 plot templates with 128 data items. So if you really need lots of plotting capability, the CPU 40 is a great option. You can also see the max storage size for each of the controllers here. You can see the 75E and the RMC 150 are the same. CPU 20L again is the same there, and then the CPU 40 has been increased quite a bit.
David, we have a
Yes.
question from the audience, and I think it would fit in nicely with this. Question is, what version of RMCTools are you using for the demos?
Yeah, great question. So I'm using the latest RMCTools right now. I'll show you. If I click Help, About RMCTools, I'm using 4.17.0, and this was the build that was released on December 1st. So this is our latest build, and you'll see that there's a few things that are a little bit different, and so that may be where the question originated from. A few more options with plotting.
Great, thank you. One more question. This is regarding your skew example, your skew limits example. And
Yeah.
the question from the audience is, would the skew be a good thing to monitor on mechanically coupled axes that are moved synchronously? Because it is a sync move, would there naturally be much skew?
Well, and so short answer, yes, it'd be really good to monitor the skew. For say pressing where we're synchronizing 4 axes together and they're all mechanically connected, we always are looking at the skew, and it's a good thing to monitor. Um, Generally, and there's kind of 2 ways that you can go about it, right? So if you have 2 axes and they're trying to be synchronized together, say you're using a sync move, they're going to have the same target position. So if you're wanting to monitor the skew so that you can shut things off in case of an error condition, well, sometimes you need to do that. Other times, maybe it doesn't matter so much, because if you get off of your target position from any one of those axes, you may have a following error set up that says, I need to be within a 1/10 of an inch, or things are going to stop, and I'll make sure that both my axes stop. So sometimes that following error is okay. But if you have, specific tolerances, maybe you don't want to use the following error for one instance or another, monitoring that skew is great. It's kind of a nice thing just to have on a plot as well, because you can put it on its own scale group, and it makes it a whole lot easier to see how well each of those axes are tracking, and yeah, see if you need to go back and maybe do a little bit tighter tuning. Okay, so yeah, great questions. Um, if there are no more, I'll go ahead and continue on. Okay. Another new feature that has been recently added is autosave. And us here at Delta, and I'm sure you guys too, if you've experienced this, really love this feature. Um, every one of your plots is going to be saved into a folder. We're able to change how much memory you want to give these. Default is 45 megabytes, but each of your plots that go into your history tab, they're going to be saved to your PC. So where this becomes very useful is, say you've been working, you've been setting something up, and maybe for one reason or another, the plots weren't saved. Um, Perhaps even the gains weren't saved, and the flash wasn't updated, and you had just spent a few hours the day before trying to get things tuned up. Maybe there's a power outage during the night, project wasn't saved, and you need to go back and see what your plots looked like before, and also maybe grab even the tuning terms off that plot. Well, these plots are all going to be saved onto your PC, so you don't need to worry about it. Um, Also very nice with troubleshooting. Perhaps you've been taking plots, but you didn't save them, and there was an intermittent error that you were able to capture at some times, but for one reason or another, that RMCTools instance closed out, no longer on your PC. Well, it's okay, because it's still in your auto-saved plots folder. You're able to rename each of these plots from your history tab. So for instance, if there's a few plots, you're going through, you're doing some tuning, maybe you want to call attention to one plot in specific, maybe you can say, rename it to a certain event or something that's happened. We're able to rename any of these plots that you've taken. We're able to clip plots too. I mentioned that earlier. I'll show you how to do it here in a second. But if you say have a plot, maybe it's 100 seconds long, you really only care about 3 seconds of it, we're able to take those 2 cursors, put them on either side of an event, and we're able to clip and create a what we call a trimmed plot. You can see that here. And then of course you can save and export any of your plots as well. So we can save these into a folder, or you can export your plots maybe to something like Excel, for instance. Okay, I'm going to jump into my history tab here. So again, I'm still in my plotting, went into history. You can see that I've got all of my plots here since I've opened this instance of RMCTools. I can also see now, and again, this is a newer feature, you may have not seen this yet, but auto-saved plots is a feature that we have here as well. You can see right now I'm at 13% capacity. What happens when you get to 100% capacity is that the older plots just start to get deleted and the newer ones are placed inside there. So you don't need to constantly clean this out. It'll cycle through itself, but just keep in mind if you're running lots of plots, you may want to increase, for instance, the memory that you're giving to these plots. You can also choose to not automatically save uploaded plots to your PC. It's set by default here in the latest RMCTools, but if you'd rather not consume that memory for one reason or another, you can uncheck this here, or you can change it to a smaller or larger value as well. And I can see if I click View Autosave Plots, I can see here where these are located. This is just an app data, Delta Motion RMCTools autosaved. So I can see all of these plots here. I just emptied this out before the webinar, or a little bit before the webinar, so you can see my latest is from the 8th. But any of these plots can then be open. Double click here, opens this up right here, and so I can grab these plots. Renaming is pretty easy. If I want to rename this, for instance, maybe call this SKU program, I can rename there. Saving a plot, again, fairly easy. I just click on the save icon here. Maybe you only want to save the SKU program, but perhaps there's a few others that you want to save as well. You can check any of the plots that you'd like to save. Click save here, and then you're able to just go ahead and save your plots. We can save them as compressed plots or a standard. Usually compressed is the best way to go. It'll take up less space. The last thing that I want to show here with the history tab is our export feature. So I can export this, say, to an XML spreadsheet, CSV, or a text file. You've got lots of options for exporting. Okay, so tuning with plots, this is something that, well, this is where plots are very much so needed. If you're interested in going a little bit deeper into tuning, we've got some nice webinars. We've got actually two of them, a basic tuning and an advanced tuning webinar that will cover the details of this. You'll see the plots being used, but our plots we're able to use either with manual tuning or an auto tuning wizard. Both are nice. In most cases, our auto tuning wizard is going to do a great job of getting you through everything. And we're able to look at real world examples. We're able to see things that maybe aren't quite so perfect as a simulator. Perhaps you've got some mechanical issues going on. With these real world examples, the plotting and the tuning are very useful. So I'm going to go through a few of these, and we'll be able to see what plots are going to look like, where you might use them. This is going to be just a standard linear tuning process. So we've got a nice step-by-step. First, you're going to add proportional gain. Your velocity feed forwards come next, followed by acceleration feed forward, and then you're going to dial in your PID. I went through that a little bit quickly. You can kind of see these plots. Proportional gain, right? It's not tracking quite so well. You add in your feed forwards, we start to get a lot closer. Acceleration feed forward is going to close these gaps between here, and then once you dial in your PID, it's going to look very nice. You can also do rotary tuning, force tuning, pressure tuning, velocity tuning. So there's lots of options within the RMC, and plots is going to be what you're going to be using for each of these. Okay, so I want to look at a few problem cases. This is the first. I'm sure this is one that a lot of people are familiar with. You can see here that we've got this problem in the beginning, right? Symptoms of this problem, plot is undershooting in the beginning and it's overshooting at the end of the move, right? So we've got an undershoot here and then it overshoots at the end. So the solution to this is going to be plotting the PID and feed-forward output terms. Now, in this case, the integral gain is what's contributing to the issue here. But once we plot these output terms, we're going to determine the best course of action. So I'm going to jump into RMCTools. I go ahead and run my my tuning setup here. We're going to go ahead and look at this tuning plot. And so what I want to do here, I'm going to say I've already seen that we're having that issue there where we're undershooting and overshooting. I can actually show you that really quickly. Let's move to a position of 10. So there's our plot, right? I can see what's going on. Maybe it's difficult understanding exactly what we need to do next. What we can do is go into our plot. We can add new quantities. And we could add each of these tuning terms one by one, but the quick way to do it is just clicking over to your Groups tab, opening up Axis Tuning Terms. Just double click on whichever axis you're interested in, and then I can see that all of my tuning terms have been added. It's a nice, quick, easy way to add all of those tuning terms. So let's go ahead. I'm going to move up to 15. Zoom in on my plot, and I can see exactly what I need to change. I'm going to get rid of some of these items so it's a little bit easier for me to see. Get rid of our output here. So I can see that my proportional term, it's ramping up here. I can see that my integral is winding up. The question would be, why is your integral winding up? Why is it trying to compensate here? If you see your integral winding up like this, usually what it means is that we need to adjust our feed forwards. So what I would do in this instance, I'm going to upload from my RMC here. So I've changed my gains so that they're not quite where they need to be so that I can get this. But what I would do is just click my Adjust Velocity Feed Forward button. You can see that a velocity feed forward has been added. This is going in the positive direction. I would do another plot where I'm going in the negative direction here. You can actually see I've got these set up right here. I'm going to adjust my negative feed forward here. You could see things look a lot better. It needs to be tuned up more. I need to work on my PID a bit more. But the problem was I didn't have any feed forwards inside there and my PID was not tuned up very hot. But you can very quickly see that with this tuning, click here, you can see with this tuning plot, now my black line, my integral output term, it's no longer just ramping up. So each of these terms, if you're not familiar with them, they all go into the RMC, they add together to create a final result, and that is what ends up being your control output. Okay, let's look at a few more cases here. So plot A looks pretty good, right? This is just a standard move. There's nothing too crazy here. Everything looks fine. But plot B looks a bit different. There's a lot more going on. There's a lot more noise in the velocity. If you have an idea of what's going on here, go ahead, just enter it in the chat. This one's kind of a tricky one, so there's a lot of things that it could be, but if you got an idea, just go ahead, enter it in. I'll give you just a minute to do that. Okay, so this might provide a little bit more clue as to what's going on here. This is a synchronous SSI feedback. This is the exact same system, by the way, so nothing different mechanically. This is synchronous SSI, and this plot is asynchronous SSI. You can see that there's a whole lot more noise going on here. It's not doing what it should be. This is getting a whole lot more noise, and it's going to be much more difficult to control. You can see that we're still controlling it fairly well there, but there's just a lot more issues that we're seeing. It's going to be difficult if we have to do something like, say, for instance, second order tuning, where we really need to watch that velocity. It's going to be a lot more difficult to put in a differential gain, because the differential gain goes off the target and the actual velocity. You're going to get a lot more noise there. So if you have a difficult system, you really want to make sure that you've got nice feedback and that it's synchronous. Analog feedback would look very similar to this as well. So here's another case. This is an odd one that we've had a few people run into. You can see here my actual position is this red line here. My target position is this blue line. So you can see I'm trying to just maintain a flat target. But my actual position, it's jumping all over the place. And my control output is right here. Again, you can see it's jumping all over the place. Sometimes looking at a plot like this has people wondering what's going on. You know, is the RMC doing something odd? Why am I getting this kind of random oscillation? So symptoms that you're going to see is the system is going to randomly oscillate. That's what's going on here, right? We're jumping back and forth. It's oscillating all over the place. Position jumps and control output tries to compensate. This is another good thing to note, right? If the control output was going in the same direction as my actual position, well, maybe there would be something funny going on with the RMC. Can't say I've ever seen something like that happen. So it's not very likely that the RMC is going to be doing something odd here. You can see that we're actually trying to oppose this motion. So the actual position starts to drift. We try to compensate, it goes the other way. It's drifting back and forth. It seems like we don't really have control over this system. So the problem is that the valve's common connection is floating. Some valves, it's easier to do this with than others, but a lot of times if you have a floating common, perhaps things will function all right for a little bit, but you'll see this issue kind of intermittently, where the spool looks like it loses control here and it's no longer doing what it should be. We've seen this issue a few times. We've just seen a lot of issues with floating commons, whether it be the valve or the transducer itself. It's a really easy mistake to make. So if you're having feedback issues or you're seeing things oscillate, the first thing that we always check is making sure that your common is connected correctly. If you're unsure how to connect it correctly, the startup guides available on our website for free, or RMCTools help. Both have great wiring guides on each of our modules. For instance, if you have an RMC 200 with a CV8, it'll show you exactly how that needs to be wired to the valve. Or maybe you have an S8, you're getting SSI feedback. It'll show you exactly how to wire it to your feedback. Generally, things like SSI, quadrature, they're not too difficult to wire up because each thing is labeled, but you can have quite a few variations of analog feedback, and in that instance, it's really nice to go to RMCTools help just to make sure that everything is set up correctly. Okay, here's another real world problem that we see a lot. This system is seeing a consistent spike in control output. So we see this very obviously on the plot. You'd probably hear this as well if you're looking at it. So again, control output is green, target is red, or light blue rather, and actual is red here. What's happening is our position is being knocked off track. So I can see here I'm following along, and then all of a sudden I jump off. Again, I can see my control output is opposing motion. That's good. right? So we're opposing this change here, and then we kind of come back and we get back to where we need to be. So what's the diagnosis here? The RMC attempts to oppose the change in motion, right? We saw that, but there's probably a physical obstruction here, and we've seen this, very common, right? It's going and it runs into something, and we try to compensate. Maybe that's part of the process. Maybe that physical obstruction should not be there though, and it ends up being a mechanical issue. Uh, that's another huge benefit of RMC plots. If you're a controls guy and the buck's being passed all around, is it a mechanical issue? Is it a control issue? Well, using the RMC, you're able to grab plots. You're able to look at exactly what's happening, and hopefully, be able to prove without a shadow of a doubt that yes, this is a mechanical issue, or well, maybe there's something we can do on the control side. So getting these plots will just help you get down to the root of the issue very quickly. Okay, so what if we have a troubleshooting issue and we need to use a plot to see what's going on here? Maybe I have a problem like this. My system faults intermittently. If I could capture a plot, it would look like this. Actual position, target position, control output, right? My control output's going down. So I've got an error here. I'm not sure what's going on, but let's say I'm not even around to capture this plot, right? Production's going to reset the controller and resume work as soon as this happens. Maybe someone isn't around who's familiar with RMCTools. No one can grab a plot. You just hear in the morning that every so often, every couple hours, they get a fault and they have to turn things off and turn them back on again to get things up and running. No plots or event logs for the issue. Plots and event logs are the two main tools that we're going to use to try to troubleshoot an odd issue like this. So our solution is going to be use a plot capture option with a program trigger. So I'm going to show you how to set up this program trigger here. Okay, so what I'm going to do is look at my trigger plot. I already have this one set up. What you're going to want to make sure is that you're in custom plot. You're going to want to add any of the information that you're interested in. For this case, I'm interested in status bits. I'm interested in my error bits because that's what's halting things out. So I added error bits to this standard plot. I also added my task 0 current program / step. So this task 0 is where I'm going to be running the program, or where you'd be running your program in production. So looking at this, I can see what program I'm running, what step I'm on. It's going to just give me a little bit more information for my plot. Okay, the other thing I did was I edited my trigger setting. Normally, this is set to enable automatic trigger. I disabled my automatic trigger. I put us on a manual rearm, so we're gonna wait until a program tells us to trigger. We're gonna make sure that we're not rearming and getting rid of the plot that's saved in memory here. And the other thing I wanted to do was set my trigger location to 50%. So for this plot, I've got a capture duration of 10 seconds. That means I'm going to be grabbing 5 seconds before my error event happens and 5 seconds after my error event happens. And that, for this, should be enough to see exactly what's going on. So if I look at my trigger on error program here, this is going to be the program that I'll be having running in the background. I've set this task to always run, to not fault on anything, and we're just going to be continuously running this in the background. So I'm going to click run, task 3, and now I'm waiting until my error bit output saturated. You could wait for any of the error bits. For this case, I'm going to say that I'm pretty sure it's an output saturated error bit that I'm getting, but I just wasn't able to grab my event log at all here. So once that happens, I'm going to be triggering a plot number 1, and I'm going to be resuming my event log. Let's see here. I'm actually going to change this to plot number 2. Let's change all of these. So plot number 2 is the one that I want to be capturing here. I had moved the plot templates around just a tad before this webinar began. Okay, that looks good. All right, so if I click capture here, I've got something that's already inside here. You can see it's grabbing 10 seconds. I'm going to start running my trigger program. Now this would be always running in the background. It's going to be waiting to see when that error happens. So when you leave for the night, you're going to want to make sure that this is running. Now I'm going to run my program here. You can see that my program triggered right. I got an output saturated. Let's see what we captured. So I can see that I've got 5 seconds before, 5 seconds after. This red line that's going down the center of the screen right here, this is right where the event was triggered. I can zoom in. I can see what my error bits look like before and after. So you can see there's no output saturated. Output saturated's on. I get my halt there. I'm also able to, let's create a trim plot here so we can see it a little bit better. I'm able to see my current program and step, so I can see that the program I'm running here, I'm running program 1, step number 2, so I can see exactly what's going on here. Step 1, number 2, I can see I'm trying to do a move absolute, and for this case, I've just got a speed that's way too high for my physical system. The other thing that I've done here is my event log has now been paused. So if they continue to run production, it's okay. You can come in the morning, you can click that capture button on your plot. It'll grab the plot out of RMC memory, and the event log will also be paused, so you can correlate this event log with the time that you have on the plots. So very nice tool. I can see exactly what happened. Axis halted, output saturated. I can see the command that was sent right before, and you'll be able to get to the root of the issue in no time. Okay, a few more things. MATLAB data acquisition. We have a great example for MATLAB as well. We've shown the one for using LabVIEW before, but the MATLAB, again, it works great. Quick examples to set up, capture data, send commands. It's basically just a ready-to-go example. I'll show you this in a sec, but this is the example that I had just grabbed a plot from RMCTools. You can see I can see everything that's going on here. You target position, actual position, target actual velocity. You can do this with many different things using RMC Link. So you can grab these plots, pull them right out of the RMC. Want to talk a little bit about newer features as well. Larger plots. So we can plot much larger plots now. You saw that the memory has increased. If you weren't aware of the limits before, they're much past what they were at that time. Trend duration versus capture duration. This is a difference that's happened in the latest RMC tools. So if you don't have that, go ahead and download it, and you'll see that we actually have separate trend duration and capture duration. Before this, they were just one, and now you get the option to set both of these. Gives you a little bit more configurability. Autosave plots, another great new feature. Highly recommend checking that out. You know, you'll be able to see that you most likely have a folder of plots already saved. And XY plots. These are a wonderful tool. Works very well. You no longer have to just plot things based on time. This plot here, I set my x-axis to control output, and I'm able to see how my position changes based on that control output rather than just time-based. So this is very nice if you have, say, something stress versus strain that you're looking at, or maybe kind of an XY gantry type system, something like that. Perhaps you're trying to follow a curve or cam based off a curve. The XY plots gives you lots of options to work with here. And I'll just show you quickly how to look at the XY plots. I can show you, I've got an XY plot set up here. Very easy to configure it. You just check this box from your template, XY plot, choose what your x-axis is going to be, and you're ready to go. So I can run XY. This is time-based here. I can run my XY plot here. You can see right now with XY, I'm generating a circle. So I have two axes, axis 3 and axis 4. It's a little bit hard to see just because of the scaling of this. Kind of set it to a 1-to-1 here, and you can see it a little bit better. You can see that I've got a circle. I've got 2 units going this way, and I also have 2 units going this way, but I've just got a circle. So my X and Y axes, they're just generating a circle here. Lots of other things you can do with XY plots as well. You know, just like time-based, there's many options, and just depends on your application and what you'd like to use them for. Okay, so in summary, RMCTools plots are great for data acquisition, troubleshooting, um, startup, tuning. There's many different things that we can use these for. Very open-ended tool, great use for many applications, and really one of the things that makes RMCTools such a nice user-friendly program to use. Okay, so what's next, right? If you're familiar with the RMCs, this might be some repeat information here. Our RMC 75, 1 to 2 axes, RMC 150, 2 to 8 axes, RMC 200. This is actually up to 64 axes just recently here. We've increased our axis count quite a bit, so we're able to do many more. Delta resources, knowledgeable Delta sales, technical support team and distributors. We've got lots of application docs, application-specific examples, hydraulic design guide. AJ's going to talk about that a little bit more here. Yeah, so really all of this RMCTools programming that you've seen is available with any of these RMC controllers. It's just dependent on your axis count. Advanced training is another option that we offer here. So if you'd like to go more in depth, learn a little bit more about RMCTools in general, spend a few days here at Delta. We have a 3-day course that we really get in depth. You get to go hands-on with many of our actual systems here, so you can control a few different hydraulic cylinders and different configurations, and just spend time if you have any specific questions for the engineers. So any more questions, AJ? All right, sounds good. Well, thank you guys for attending. AJ's going to quickly go over hydraulic design guide and where some of these resources are available. But yeah, thank you again. And if you have any questions later on, feel free to reach out. More than happy to help with anything you've got going on.
Thank you so much. We'd like to thank all of you for taking time out of your schedule today to attend the webinar. We really appreciate the interest. And as we look forward into 2021 and as we plan, we're looking forward to bringing you more hopefully useful information. As we mentioned, we offer a free design guide. It's a paper copy of suggestions that we have for considerations for designing hydraulic systems for optimum control. Fluid Motion Power Control, a guide to practical design. And if you go to our website, deltamotion.com, you scroll down about halfway down the page, you'll see that icon just like that. We ask you to enter your shipping information. We'll ship that right to you. We wanted to mention, David mentioned it in the course of the presentation, we're very excited that RMCTools 4.17.0 is released. You may have seen a mass mailing. You may have seen it on our website if you want more information about it. But that it enables some really neat and really exciting features of the Delta RMC motion controllers. So we can now support up to 50 physical axes in the RMC 200 platform. We have also released the RMC 200 Lite. That consists of the CPU 20L CPU and it has an integrated power supply, and that's designed for smaller axis applications up to 18 axes. All of this information is available. If you go to deltamotion.com, you'll see the image there on the landing page. We mentioned recordings at the top. As usual, if you would like to catch a recording of a previous webinar, deltamotion.com. If you navigate to the education section, you'll see the link there to the webinars. That's also where we have information on linking to registration for upcoming topics. We have a discussion forum where the webinar recording links are posted. It's at forum.deltamotion.com. You'll see the webinar topic located there. And then if you'd like to go to YouTube, we have a YouTube channel. Just search for Delta Motion Control, all one word.